Okay, just talking to myself again. Dr. Richard Carey just sent out an email about his new article or blog post he wrote on how quantum consciousness is BS. And he does not allow any comments to his blog post unless you pay him money. But it's actually, he makes some interesting comments. He cites one of the collaborators of Basil J. Hiley, whose name I cannot pronounce. I don't think it's Finnish. Paavo Pylkkänen and this guy Paavo. And so and then he cites a paper by him, and he says that Paavo promotes weak cognition, quantum weak cognition. Hello, if you caught me in the middle, you can. I'm just gonna keep talking, and feel free to comment along. But anyway, if you actually read that link to the paper, this is what he says. He says that Richard Carrier. He says that this guy Pavel is a leading proponent of weak quantum cognition, and then he links this paper that I just linked in the chat. So if you go to that link, the paper's from 2013, but in fact, if you read the paper, he is not a proponent of weak quantum cognition. He's a proponent of strong quantum cognition of David Bohm and Basil J. Hiley. And so this is proven, of course, if you go to the links in the video description. Sorry, I got chocolate on my lips. Cocoa. That Basil J. Hiley has co-authored a paper with Paavo Pylkkänen, and also that the three of them, Pavel and Basil J. Hiley, and then Roger Penrose, who's also cited in Richard Carrier's paper, they all presented together at a symposium in 2021 in Finland, where Pavel works. So, oh, really? That's interesting. I wonder, well, okay, it probably is because Tim Ventura actually did interview Pavel recently. And I know Jack Sarfati, since he's been interviewed by Tim Ventura, then he follows up on Tim Ventura's uploads. But what's interesting is if you watch that Tim Ventura interview of Pavel, he does not mention Basil J. Hiley at all. Or he might mention Basil J. Hiley, but he doesn't mention non-commutativity. And this is my point about Richard Carrier, is that if Richard Carrier actually, well, the other thing is that at the end of the Richard Carrier's blog post today, he talks about Gao. This is what he says about Gao. And okay, he says that, okay, that's a quote from that article. Now, he doesn't realize that Gao has a 2022 book on quantum consciousness that has a book chapter by Pavel and Basil J. Hiley. So if Richard Carey had just dug just a little bit deeper, he would have realized that this person that he's dismissing, Gao, actually is promoting Pavel's work that Richard Carey is calling weak cognition. Now, the whole reason that Richard Carey doesn't understand this, or he, didn't notice this, he needs to dig deeper, obviously, because Richard Carey, he's actually like a I don't know, like a history professor. His whole thing is of being a skeptic, a religious skeptic. So he uses statistics to then debunk Christianity and whatnot, and he relies on uh, whatever statistics to do this. But so he doesn't understand non-commutativity, which non-commutativity is, as Basil J. Hiley points out, that you don't need statistics in quantum physics if you rely on non-commutativity. And the other thing is that in non-commutativity, you're not limited to the collapse of the wave function as the quantum measurement problem. And this was Basil J. Hiley's big point to Roger Penrose when they gave the talk at the Mind Matter Symposium. And I linked the talk in my video description. I could put it in the chat again if people are interested. But yeah, here's the here's that. It used to be a private listing on YouTube, but oh wait, hold on a second. Yeah. Okay. Sometimes the link, the copy thing is weird. Okay, there we go. So anyway, if you click on that link, that proves that Basil J. Hiley, he is actually talking directly to Roger Penrose and with Paavo Pylkkänen or how Pylkkänen. Anyway, so that proves that Richard Carrier, he just did not dig deep enough, and he doesn't understand non-commutativity. And so he has this. It's most scientists are very quick to like dismiss quantum consciousness and even quantum biology or whatever. And of course, even worse, even most quantum physicists, they don't really understand non-commutativity. So when I debated Jack Sarfati, he just insisted that the Heisenberg uncertainty principle is non-commutativity. But if you study Basil J. Hiley, he makes the opposite emphasis that the Heisenberg uncertainty principle has nothing to do with non-commutativity. And I mean it does. There's a connection, but that's his Basil J. Hiley point, is that you're misunderstanding it if you try to say so. Anyway, I mean, I don't want to go into the weeds of the whole mathematics of it and stuff, but because in terms of quantum biology, if you understand it as non-commutativity, then that leads you to Eddie Oceans, who he realized the secret of what he called quantum psychology is non-commutativity. So the thing about non-commutativity, as Basil J. Hiley points out in that 2022 book chapter that I put in the video description, but I'll post it here too. If you read this article near the very end, yeah, so it's the same guy, yeah. Yeah, Jack, I mean, I like Jack. He's I just disagree with him, and he's the thing about non-commutativity, because if you're trained as a scientist, then you're totally steeped in commutative geometry, and mathematics is the language of science. So it's like mathematics is sort of like the background to science. And if you're stuck in the wrong mathematics, then you're going to be brainwashed and you can't help it. And so Basil J. Hiley, he's it's very rare that he figured out that the secret of quantum physics is actually non-commutativity. And strangely, I came at this. I took my first quantum physics class. I took quantum physics my first year of college, and it happened to be a colleague of Jack Sarfati. Jack Sarfati was in graduate school with Herbert J. Bernstein, and they were friends. As Jack said, they weren't bosom buddies. Anyway, so the thing is that my professor, he said that everybody should learn quantum physics as their very first physics class. Otherwise, they're brainwashed by the wrong foundation of reality. And that was my approach too. I did not take physics in high school. I took biology, and I was very skeptical of like commutative geometry at the time, even the Pythagorean theorem, because I was approaching it from music theory, and I had my own take on music theory that turned out to be non-commutativity. And then when Basil J. Hiley taught us the Dirac dance, which is basically like you go like that, and he's like every 0 point of space-time has that non-locality going on. That's a 720-degree spin from the 1/2 spin of the electron. That he didn't call it non-commutativity, but that's what it is. And so even most people, when they learn quantum physics, they don't learn from the Dirac dance, because the Dirac dance goes beyond Schrodinger, the Schrodinger wave equation. And then my professor, he held what he called Bohmian dialogues based on David Bohm. So he followed David Bohm's model of quantum physics. And then, Basil J. Hiley, in his collaboration with David Bohm, he realized that actually Richard Feynman was wrong, and Schrodinger was wrong, and and that the truth is non-commutativity, and you have to rely on Planck squared, which I don't, again, I'm not going to go into all the details, because Basil J. Hiley, he goes into that. If you want to learn all the technical details on the math or whatever, but in terms of the meaning of it, is because Richard Carrier, he's like a critic of theology, right? And so in terms of quantum consciousness, it comes back to meditation and in theology, because that's what religion, you practice prayer and meditation or whatever in religion. And so Basil G. Hiley's point is that quantum biology has been completely misunderstood up until, because it's ignored non-commutativity. And so the thing about non-commutativity, it's not limited to the quantum scale. And the other thing about non-commutativity is that it's non-locality in the sense that it's the origin of reality. So like this professor Sean Majid, he focuses on non-commutativity, and he points out that non-commutativity would demonstrate that black holes do not actually collapse, because the quantum non-locality, it creates an anti-gravity pressure that cancels out the logarithmic singularity of the gravity. And so you have a wormhole that's that's traversable by this, what Roger Penrose calls proto-consciousness. So the proto-consciousness of the universe is what Roger Penrose says then survives the acceleration of space-time and at the end of the universe, and then before the Big Bang. And so it's not just photons, but when you have the Hawking radiation as a quantum entanglement, it actually is this quantum non-locality. So he's saying that only time and frequency exists with no sense of spatial scale. There's no sense of size. and that's well known from the photons. But the thing is that what doesn't get noticed in Roger Penrose's um, cyclic cosmology, what does he call it? Anyway, the CCC. I can't remember but he's pointing out that time is not only very asymmetric, but it's also highly coherent and very low in entropy at the origin of the universe. And he's saying that that completely goes against um, how the origin of the universe is normally considered, because you have um, it's considered where you have a big explosion, and so the explosion would create entropy, but in fact, what's happening is that in terms of gravity, the its potential gravity, that's highly coherent due to this asymmetric time. So he's saying that potential gravity actually originates from asymmetric time, that's this quantum non-locality. and and so what they call dark energy, he says, is actually just gravitational potential energy from that originates from this quantum negentropy, negative entropy, from asymmetric coherent time frequency. And that's another way of saying non-commutativity. And so Roger Penrose, he even published a paper on non-commutativity as the foundation of reality of the universe. And then he says that, well, he's not very good at non-commutative math, and that it's a nuisance, for him. And when he published the paper, he co-authored it with somebody who specializes in non-commutative geometry. And so like so this Richard Carrier guy, he dismisses Roger Penrose as a crank, or he says he's not a crank, but he's wrong. But Basil J. Hiley, he was pointing out to Roger Penrose, it's like, look, if you have non-commutativity, then you're not dependent on a physical source of consciousness in the brain. It's only all you need is just thermodynamics, where you have a difference between temperature based on frequency and heat as a dynamic of energy. And so the negative entropy is what if you study Yakir Aronov, he says that color is not a visual illusion of our brains, but the frequency and wavelength of color is actually a way to avoid the logarithmic singularity, or what it would actually be, it's an asymptote as an exponentiation of in what they call the black body radiation problem. So you have the color, the ultraviolet catastrophe, the actual frequency as the quantum frequency of energy as color is the way for nature to avoid that logarithmic singularity. And how it does it is through the non-commutative frequency with time. And so if you study along Khan, he explains, how the Heisenberg discovered that the temperature change, the energy in quantum physics based on the frequency of light is actually a transitional frequency, and that transitional frequency is non-commutative, and so it changes based on the direction of space-time. And so that's why, like, the very definition of time in physics now is based on the cesium frequency. And so along Khan, he's emphasizing that time is no longer defined by space-time. It's directly a quantum transitional frequency that's non-local. So what they do with cesium is they do a quadrature, like they square it. So they have the both directions of time. So you have negative time and positive time, and then you square it, and that's how you get this standardized definition of time. But if you just take a single transitional frequency, then you get this asymmetric time that's inherent to reality. And so this is what Lee Smolin has been emphasizing lately. Lee Smolin, if you watch his latest talk on the theory of everything, he's saying that the origin of reality is chiral. By chiral, he means chiral meaning asymmetric, and that's another way of saying non-commutative. In fact, I linked on my blog that Lee Smolin's latest paper that he had published a couple of years ago is all about non-commutativity. And I had and Lee Smolin's first physics professor was Herbert J. Bernstein, also Herbert J. Bernstein. The same physics professor that I had at Hampshire College. Only Lee Smolin was there like in the 70s, and I was there in like 1990. So anyway, I emailed Lee Smolin a couple times about this, about non-commutativity and quantum consciousness or whatever. I can't remember what I emailed him because he never replied back to me. And I sent him an email lately because he, in that same talk on the theory of everything, he talks about his Parkinson's. He's been diagnosed with Parkinson's, and he says that he thinks it's chiral, it's asymmetric in origin. And so I said, well, they've done, somebody healed themselves of Parkinson's using qigong healing, and that the secret of qigong is this non-commutativity, is asymmetric time frequency energy. And so in a sense, it's come full circle for Lee Smolin, because it's like if he wants to treat his own condition, then he has to actually practice this, what he considers to be the truth of reality, which is this chirality. And this is what my 2012 book was about. My book, Alchemy of Rainbow Harp Music. It's all about chirality, and I didn't focus on non-commutativity because at the time I was just focusing on the problem. I was just saying that because science has been based on symmetric commutative geometry, therefore we have all of our problems right now. The whole existential crisis of the ecological crisis and the social justice crisis. And so scientists are actually indoctrinated by the commutative geometry math. And so they follow Platonic philosophy, and they might not admit it, but then, and that's why they're biased to have this optimistic worldview where they, like I was just watching Henry Gee. He's the editor of Nature, the top science journal. He's a science editor for Nature, and he's like, well, he's optimistic that humans will survive, and he's like, well, the mass extinction of species. He's like, well, it's not really happening right now. It's only going to happen in like 500 years, and that's just not true because we have. I studied conservation biology in 1992 for a semester in Costa Rica, and that's when E.O. Wilson's book was published in 1992. And as a conservation biologist, he said, the mass extinction of species is going on right now. And obviously, if you're clear cutting rainforests where 50% of the biodiversity of life on Earth is, then you're going to have a mass extinction of species just by clear cutting. You don't know what was there, and you're just wiping it out and replacing it with like soybean farms by Cargill. And so my point is that the top science journal in the world is science. They have a bias that's an anthropocentric bias, and not only that, they're even dismissive of life on Earth, because he's like, this guy Henry Gee, he's like, well, he studies the ancient his latest book was like a brief history of life on Earth. And it's fascinating. He's like, well, 50,000 years ago there were five different humans, five different types of humans. And and then soon after that there was only the modern humans that survived. And so he's very much fascinated by the deep time of life on Earth, the deep geological time. And but then he extrapolates that into the future, and he's like, well, deep into the future, um if we have life from other planets that visit Earth, they'll never know that humans existed. And it's like, okay, well, that's very nice, that's a convenient thing to say. It's just very dismissive. Anyway, I got to get going. So, anybody, any other comments or questions, and I'll sign off here. I got off on a side tangent there. Okay. Well, you could check out the links in the video description that I left on Richard Carrier's article. And you can't comment on his article unless you pay money to comment. See you later in Australia. All right, signing off.